everyone. Hope you like it. How many of you relate, by the way? Who started like 2 decades ago? Doesn't matter, I can't see you anyways. Yeah, I can. I started like 2 decades ago. Being through all that, seeing all that, man, it's interesting. Anyways, welcome to the, I need to make this thing work. Welcome to the Decomposing Java Applications talk today. My name is Milen Dyankov, and I work for Liferay as a developer advocate, which basically means spend quite a lot of time these days talking to developers on events like this, and not only about how they do software, how can we help them do software, how can we help them do better software, what problems they solve. And at the same time, I've been through pretty much every single role in software industry, from like developer through consultancy and developer advocacy. I've seen it all. And also, we as a company, I don't know how many of you are familiar with Liferay, but if you are, you probably know that Liferay used to be a product, a portal product back in the old days when the portals were super cool and everyone was excited about portals. Things obviously move forward, and one of the exercises that we've been going through for the last several years is trying to split a big, huge monolithic platform into something that actually can work with and reach the point where if you touch something here, nothing breaks over there, which I don't think it's an uncommon problem. So we split it into a bunch of other frameworks, tools, libraries. Some of those are still on the market, being used by large enterprises. Some of those are gone. But it's not that I want to get you sold on our products. It's the experience of like that I went through with a bunch of people from other teams of like how you design a software, how you build a software, so when the environment around you changes, you can actually adapt to it. And it turns out it's very hard. It's very hard to talk to people because everyone has their own vision of how the things should look like. And I was like trying to figure out a way to communicate, to find this common language, so we all talk about the same thing. And then I realized it's kind of the same problem I'm going through with my kids. I have 3 kids, school age. How many of you parents, by the way? Not that I see, but I assume some of you are. So you kind of understand probably the problem is, like, you go to your kids and you say, hey, you know what? It would be nice if you clean your room. And they look at you with this like very specific way a kid can look at a parent and say, what do you mean it's clean? Or if they are as my son, they would look at you with this other very specific look and say, define clean. So, you know, we use the word clean, and now we have a pretty good understanding of what clean means, which does not necessarily mean that is what my kid or your kid understands by clean. And yet, that's how we communicate, by a word. So this is the subtitle of this talk, Cleaning and Tidying Children's Room, because I think it's pretty much relevant in terms of how the communication goes. Now, typically, this is the point where I ask people, how many of you are familiar with the Conway's Law? I don't know how many of you, and I won't be able to see it anyways. So for those of you who are not, the Conway's Law, and in this era of microservices, you probably should be. But anyways, it says that an organization that designs a system inevitably is going to produce a system that reflects or represents or is a copy of the organization's organizational structure or communication structure. Just in other words, the way your company is organized is going to heavily influence how you build software. Now, well, you can argue whether that's true or not, to what extent that is true. What I find interesting about that, Conway's Law, is that assuming that is the case, assuming that is true, what you can do is you can revert it. And you can say, well, if that is the case, then we can get pretty much any piece of software and represent it as a company communication organization structure, which brings us an interesting perspective to look at a software. Now, this gives you the ability to actually use I call it, I'm missing the English word now, analogies. So to visualize why different ways of doing software make a lot or make no sense. Okay, and so this is what the whole exercise of today is. I'm not going to be talking to you about building software. I'm going to talk about building companies, which kind of has a lot to do with building software. There's a lot of code, a lot of demos. Basically, 90% of the talk is demos. So all of the code is on GitHub if you want to go play with it. I'm going to go through the code fairly quickly. It's not the point of this talk for you to understand every single line of it. It's more about how is code organized, why we divide the thing the way we divide it, and things like that. But if you want to explore it in details, feel free to go on GitHub and play with it. Okay, so let me introduce you to Harry. Harry is our hero, the main hero of this presentation, and he wants to start a business. And his business is going to be cleaning. He has a van, he has some tools, he has some supplies, and he's going to start a business. He's going to be cleaning houses. So customer is going to call Harry and say, hey, Harry, want my house clean. He gives them the price, they pay him, he cleans the house. Pretty simple, right? Startup. Okay, so how do we model that? Put it here. Okay, let's have a look at one possible way. There's an example here. And this is Harry. Say hello to Harry. Harry can do things. He has things. He has tools, he has vans, he has supplies and stuff like that. He can do things. He can clean houses, right? That's pretty cool. So the process is like this. He requests some money, you pay him, then he picks the supplies, then the tools, the supplies, then he sits in his van, drives to a given location, then he's cleaning the house, then he's driving back, and finally he's putting an income in some kind of bookkeeping system. Pretty straightforward. As I said, don't try to follow up with every single line of code. That's not a point. The point is, Harry is a person. And as a person, Harry can also do other things. He can borrow his van to someone, for example. But he doesn't borrow his van to everyone. He can borrow it only to his friends. That's why you have a friend check here. And it's the same thing with, sorry, that's the borrow van. And the same thing is with borrowing his tools, right? He can borrow his tools to a friend, like no big deal. So why not, right? So how that works. And I need to, let's clean this. My demo's still running. Okay. Forgot to clean, so let's go to house cleaning, and that's going to be not here, but here. Example 1. Okay, so I have this in pretty much every demo. I have this client code that just talks to Harry, so don't pay attention to that too much. I'm just going to run this, and I have this run script here. And when I run it, I have to say which Java version I want to run it with. And you'll see later on why that is important. For now, we're going to just run with Java 8. So I have this way to talk to Harry now. And I can say, hey, Harry, I need to clean my house. And Harry goes like, yeah, sure, assuming I've paid, because the first example doesn't really treat the payment stuff. But anyways, so as you can see, he processed the stuff, gets the tools, the supplies, loads the van, drives, cleans, drives back. Well, just following the process. How do you like that? How many of you write applications this way? I mean, those of you who are not on the first year at university, because that's how you write applications first year, right? First time you start writing applications, that's what you do. It's a single logic, like do this, do that, do this, do that. And that's pretty cool, actually, if you think about it. You know why it's cool? Because think about what happens if something goes wrong. There's one place to find it. That's Harry. Everything's there, right? You don't have to dig through millions of Java classes and modules and whatnot. It's all in one place. Super simple. So why don't we build applications this way? Because it's not scalable, obviously. Now, Hari can only do so many things. Like, Hari cannot be a corporation cleaning thousands of houses per day, right? It does not scale. So Hari realizes that and said, okay, I'm going to change this. Okay, clear that. And I'm going to introduce a different company structure. So I'm going to hire Ronald. And Ronald's going to be taking care of orders, all the communications with the client, and blah, 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 and I'm just going to do the cleaning, right? Ronald has this order form thing, blah, blah, blah. And now he also thinks like, well, what those things, like, they're not me, like Van, and they belong somewhere else. So he has this thing called Smart Garage. He puts the stuff there, right? So it's a little bit different organization, but pretty much the same thing. So let's look how that works. So here is the garage, where he puts things in it. And Smart Garage, it's smart because it can do things like this, right? Not that Hari needs one, but everyone in the industry uses one, so he uses one as well, if you know what I mean. And then you still have Hari. Like, Hari can do his thing, and you have now Ronald with his order form. So, yeah, pretty much same thing, a little bit different structure. So let's see how that works. So we're going to go to house cleaning example 2. Run that with Java 8 again, and let's see clean house. And you see the Smart Garage is so smart, it gives us immediately what tools we need. Then you can see that Ronald is processing the form nowadays, and so forth. So everything works just fine. Now, I didn't show you something in the previous example. I forgot. But anyways, it was that, let's quickly do that. And let's go back to house cleaning 1, just so to demonstrate the purpose. So what's going to happen in here if I say borrow van? That's first example. Well, Hari say, I don't know you. You're not my friend, right? But I'll say, no, I am your friend. You just don't remember. And then he's going to borrow me the van, and I'm going to grab the van, go on 3 weeks vacation. Hari's out of business. That's a different story. So that's example 1, and that's one of the problems Hari wants to fix. Not to fix, but like one of the things that he wants to keep, right? So let's go back to our example 2 now. Let's see if this still holds. So we run this, clean the house, as you can see, still works. But what doesn't work is the way we expect to be, is if I say borrow van. Then I get the van immediately. Like, Hari doesn't ask me if I'm friend or not. Like, why is that? Because what we have done is we introduced an organizational structure that allows Ronald to skip Hari. Just go to the garage, get the van or the tools or whatever, and lend it to whoever he wants, right? And Hari has no way of knowing that. And then you're like, oh, wait a minute, if you are Hari, that's not how things work. We need to restructure this company. Like, if I end up with growing my business with thousands of Ronalds around me, that simply is not going to work, or it will work, but it will be unmaintainable. And so he looks around, smart books, people, conferences, tells him that most people do organize companies this way. So you have this thing called front office or whatever, where you handle all your customers, and then your company is where your people, staff and things like that, and then you have all the assets. So Hari goes do that. He puts the van in the garage, he introduces the storage, he hires Andre. Andre is responsible for the storage. Like, he's the storage keeper, right? Hari deals with the garage, and Ronald is dealing with the order form. And in terms of code, this could be represented by this example. So we now have 3 modules, right? Like this is another big word, like modules. Wow. But essentially, it's 3 jar files in terms of Java, but that's a separation. So we have the assets here, and this is where the garage is and the storage is, boring. The client is the communication part. So in the company, we have Andrei and Harry. Now, one thing about Andrei that you need to know is Andrei is not publicly available to anyone. He doesn't talk to other people other than sitting next to him, which is Harry, right? So no one can talk to Andrei directly, only Harry. It's pretty good security. And then we have the front office, where is Ronald with his order form. Okay, pretty good separation, I would say. Right, I think you agree. Let's go to example 3, make sure it works. What happened here? Okay, CliHouse. Yeah, it works. Okay, so can I borrow the van now? Sure I can. How'd that happen? Well, we didn't solve the problem. We separated things in a different way, but still, Ronald has full access to the garage, full access to the storage, so anytime he wishes, he can just go grab whatever he wants, and there's no way to control that. And now you say, well, wait a minute, you did this wrong, right? You should have the garage and the storage protected, right? Or not public at least, so Ronald cannot access them. The thing is, if you try to do that in Java, you're also going to protect Harry and Andrei from accessing them. So you can't really, so you have like all or nothing situation. You either give it to everyone or you give it to access to no one, right? So you can't fix that this way. So what's the option? Like, there must be an alternative. But before we talk about alternatives, how we ended up here. Now, some of you will say, you know what? That's totally wrong way to design an application. No one does this. You don't, right? Except you do. And I did. And then pretty much everyone did for a decade or so. Because this is what I call the universal BBC architecture. A box, cylinder. Now, in reality, we don't call it box, cylinder. What we call it is a front-end business logic database or some other fancy name. But this is what we've been taught for, I don't know, a decade or two. That is the best architecture. 3-layered, rings a bell. The best architecture for applications, and you have no idea how many applications are built this way. But apparently, it has problems which Harry wants to solve. So he moves, he goes on, reads more modern stuff, and he comes up with new architecture. And he goes, okay, I'm going to do a different separation now. I'm going to have my front office with Ronald in it. I'm going to have the company with me in the garage. I'm going to be protecting the garage. No one can access it directly. And then I'm going to have this back office with Andrei in the storage, and Andrei is going to protect the storage. So garage and storage, no one can access them directly, right? And that may solve the problem, actually. Well, let's have a look. Okay, so this is an example for pretty much same separation. Again, 4 modules. So front office, again, is order form and Ronald. The company is garage and Harry. And garage, you can see it's not available to anyone. And the back office is where it is, Andrei, and Andrei is protecting the storage because only he can use it. Right, so pretty cool, huh? This should work. So let's exit this example and go to example 4, run that. First of all, check if it works. So CliHouse, yeah, works, great. So, can I borrow the van? What do you think? Yes, no, shout. No. No, because Harry now is in charge. He protects the van. So he's going to ask me if I'm a friend or not. So we achieved the Well, we wanted to, right? Except, can I borrow the tools? Of course I can. Now, wait a minute. We were supposed to be protecting things. How'd that happen? Well, that happened because while Andre is protecting the storage and Ronald cannot go directly to it, now Ronald can talk directly to Andre, and Andre has no idea of what rules Harry is using to decide whether he can borrow something to someone or not. So you have a different type of problem this time. You have a situation where either you're going to have all your assets protected by Harry, or Harry has to go and explain his business logic of protecting stuff to pretty much everyone else. Doesn't sound like a very scalable solution, yet this is how people build applications this day in what I call the universal microservices architecture. You put all of your stuff in a box, your database, your JVM, whatever. The box could be, Docker, whatever the coolest thing of the day is, right? And you're pretty safe, and you deploy it with Kubernetes or whatever, something. And that's super cool up until the moment you realize that you reach the point where everything has to talk to everyone else, or there is a tons of shared logic that you need to duplicate between those services, otherwise they're becoming inconsistent, right? Well, yeah, that solves some problems, but it doesn't solve all problems. So what do we, it's like, no way? Well, no, we can think of other things, and Harry goes and searches more and figures out that he's been doing it wrong all this time. Because what he's been focusing on is assets, like the van, like the tools, like the Harry and the Ronald and the Donald and whatnot. And he's been building all this business about the assets, about the items. And business is not about that. Business is about processes. It's about interaction, about communication, about get things done. So at the end of the day, if you think about a business, like, no one cares how your company is organized. No one cares how many people you hired. What people care is what they can request and what they can get and how much it costs them. So it's the interaction. I want this from you. It costs me so much, so I'm willing to pay the price or not, and you do the service or not. So now Harry thinks of organizing the whole architecture around processes and not around people and assets. So he's going to have this thing called company, and inside that thing, he's going to have all the things that make a company, which is people, job position, processes, blah, 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 whatever. No one cares about that. But he's also going to have this thing, which is in here called use cases, which defines what this company can do for someone. Right? And then he's going to have this thing called front office, which is essentially your point of interaction with other people, right? But those interactions are limited by the use cases, so you can't do more than the use cases. Now, if you think about that approach, that allows you to scale, because scale one thing without necessarily having to scale the other. So you could tomorrow introduce, Harry could tomorrow introduce another use case, let's say cleaning pools or cleaning backyards or cleaning cars or whatever, and he can still use the same assets that he has in the company. Or maybe he needs to expand the company, but those are two separate things nowadays. The same way, he can introduce different ways of interacting with his clients. Say, you don't have to open the front office, but get stuff through the internet or email or whatever, without having to change any of his backend infrastructure. So this decouples the processes into where your interaction happens versus what you offer versus what you actually possess. Now let's see how that works in terms of code. So this is an example 5 here. And so we have the company, And inside company, we have separated things into several sub-departments, which in Java we call packages. We have things here like assets, which is where all these things goes, like storage, vehicles, blah, 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 boring. Then you have job positions. And see, you have, for example, an accountant job position. And if you think about it, what is a job position? It is a description of what the person who is in that position can do. It does not say how, it says what. Things like that in Java we typically call interfaces, right? Then we have processes, and inside here you have something like clean house process, which is pretty simple. You just get someone in a position cleaner, then he cleans the house. Then we also have something like transport process, which is you get something like a van or a vehicle loaded with stuff, drive to a particular place. That's what the transport process does, and so forth. So you have these processes that makes things work. Okay, and then you also have some shared stuff here because you still need to share some data between departments in your company. And then you have stuff like people, like for example, Andre, who is an assistant. And now, there's a number of different ways to be an assistant. This is, below here, is how Andre does it. This is how he does the work that is assigned to him. No one cares for as long as the work is done. And so is Hari, who is, say, cleaner and accountant, because why not? And this is how he does this work. And no one really cares for as long as the work is done. Fine. So that's the company, and that's the thing that no one cares about. Now, what is in the use cases? Well, use cases defines an interaction. So here is this thing called customer use cases, and here you see how we have the clean customer house use case. And in this use case, you basically say, well, in order to get this done, I need to employ this processes. So I get a new order process, prepare, clean the house process, transport process, and then, you just use the process. So this is how I process an order form, this is how I get to the house, and stuff like that. And your front office is basically the same thing, interaction, except it now interacts through use cases. So how that works? Let's see. And clean that. So let's go to example 5 and run that. And request to clean the house. Oh, I added the amount here. Fine. Yeah, it works the same way. Well, you can see it's still Ronald who processes the form. It's still Andre who prepares the tools and stuff like that. Except it doesn't matter in this case because we need someone in the role and not a particular person. Cool. So that works. So can we borrow the van? What do you guys think? Of course we can. So wait a minute, we did all this changing, like we restructured our companies like so many times, and we still haven't solved the fundamental problem. Like why? Because you still can access all of those company resources from these other departments. Nothing prevents you from doing so. And if you have smart enough developers, workers at your front office, there's nothing that prevents them from like bypassing you and getting what they think they need and what they think it's the easiest to solve the problem, right? So looking at that, what do you need? Like, how do you solve that? Like, Hari's like, oh my God, like I need to solve that problem. And the only way to solve that problem is to make those internal stuff that is only for the company unavailable, hidden, right? And the question is, how do you do that in Java? Well, if you are on Java 8, your options are limited to something that I'm going to go to later on. For now, we're going to go with Java 9. Because Java 9 and every single version of Java after 9 will actually allow you to solve that problem due to the thing that appeared at Java 9 that is called JPMS. Java Platform Modular System. So if you ever wondered why in the world they did that thing to Java, now I hope this is going to give you the answer. So house cleaning 6 is basically the very same example as the 5. Nothing changes in the code, except we have this thing here called module info. And in module info is the new thing that comes in Java 9 and every newer version that tells Java what is available to who. And in this particular case, for the company, we basically say house cleaning job positions, processes, and shared are the things that should be available to other people. Everything else, no one should be able to access because it's internal. No one cares about that. Now, if you look into the use cases, now there's still module info, and in module info we basically say, well, only use cases are available to everyone else, but we do use a module called company, and that means we can get access to everything that company exports. Okay, and then the same thing is in the front office. If you look at that, well, it exports front office and it only imports use cases, so you can't access anything else. Now, to make this work, you need to, so let's do this. Let's go to house cleaning 6 and compile this. With Java 8. It's going to take a second to compile. So we compile this with Java 8. You see, it compiles just fine. And then run this with Java 8. Now, Java 8 has absolutely no notion of modules and this type of things. So if you do borrow van, it will just work. No surprise here. But let's try to build this with Java 9. Trust me, it's going to be the same with Java 11. It's just too old example, and takes a while to update it to run with 11. So imagine it's 11. So let's build. Wait a minute. It doesn't even build. Why is that? Now, if you look at the error messages, what you're going to see in here, it says company internal assets is not visible. So it basically says you're trying to access something that you're not allowed to. And then light bulbs go on and you go like, oh, wait a minute, what happens here? And you go to your front office to code, and you look into it and say, hey, wait a minute. How come our front office offers to borrow a van? That's not a service that we as a company offer. So no, my dear fellows, you can't do that anymore. Right? You're not allowed to do that. So you get this fixed. And then you can compile with Java 9 again. And now, surprise, surprise, it all compiles. Now, since you did this with Java 9, what you need to do is run it with Java 9. So you can run it with Java 9 on module path. And just for the record, clean house still works. But now, borrow van does not. And borrow tools doesn't either. Yay, 6 iterations, and we finally managed to achieve what we wanted to achieve. But now, you know how it is in software. You solve one problem and the next one pops up, right? So what's going to happen if, for example, our van breaks? So here, I have a file which indicates a van failure. So I'm just going to make our van not working. Okay, and then I'm going to run clean house again. Boom. the van is broken, so we can't go to the customer. So one of the processes that we need is not there. So we are the business. So we need to sit down and wait for someone to fix our van. And you know all businesses work this way, right? The moment something breaks, they close down. No, of course not. But we do that in software all the time. So how do we tackle that problem now? Like, what happens if things break? Like, van is just one example. Well, Harry goes and reads more about how businesses deal with that and realizes there is another layer of abstraction that businesses often use, which is called services. Yeah, I know, that's the moment where you think REST and Docker and Kubernetes and all. No, services, just like that. Services. Implementation details doesn't matter. The point of a service is that what the name says is something that someone does for you. And how it does it, it's an implementation detail. See, if you want to go stuck here, all the RESTful and Docker and all this stuff, fine, go do it. But you don't have to. You just think services and not microservices, web services, whatever. So how do you do that? Is there any way to do that in Java? Well, turns out there is, surprisingly. How many of you are familiar with Service Loader? And I really need to see that. Anyone? Service Loader rings a bell? One person. That's what I thought. That always happens on talks when I ask about Service Loader. Well, surprise, surprise, Service Loader is something that was introduced in Java 6.
It's Spring's fault.
Sorry?
It's Spring's fault that nobody knows about Service Loader.
Yeah, someone said it's Spring's fault. I won't argue with that. I'm not saying I agree, I'm just not going to argue. Political correctness. Well, wait, Mark Heckler is doing talk in the next room, so he can't hear me. Yeah, so you're right. Okay. Wait a second. What I was talking about. Oh, services. Okay, so we're going to go to example 7, which is a little bit different than what we had so far. In this case, we have again the company. And in here, we've done some small changes, particular to our processes. So instead of having solid processes like we had before, what we now have is a process definitions. So if you look at the transport process, it's now a process definition. It basically says if something is a transport process, it's supposed to be able to go to a particular address, right? And we also have a definition of, say, clean house process, which is, given the cleaner and instructions, it's supposed to clean house and stuff like that. So now we also have here an internal implementation of those processes. So here is the internal transport process, which basically means, our process is like this. We get our van, we load it, we drive, blah, blah, blah. This is how we implement the process internally, and so forth. Now, from the other perspective, the perspective of the consumer, not much changes. They still use the processes, but how? Well, things have changed in Java 9, and now the definitions of services are in module info as well. They used to be in some other place, which I'm not going to talk about. But nowadays, you can do this with the newer version of Java. You can say that a module provides a process or service, any kind of service, with a particular implementation. So we say that a transport process is provided by internal transport process. Now, on the consuming side, let's go to the use cases. So we have a very similar thing. It says, well, this thing uses a new order process, clean house process, blah, blah, blah. But how do you get the actual implementation? Well, sadly, that's a lot of boilerplate code in Java. So customer use cases, this is what the code looks like. You basically have to go to service loader, load, blah, blah, blah. I'm not going to bother you with this code too much. But at the end of the day, this is how you get an implementation of a service. This thing called service loader is going to go do his magic and give you a service. Okay. So what you can do with that now? So you can go to the next example first, and run this with Java 9 on modular pod. And you can do clean house, and, well, it works. Then you can break the van, and it doesn't. So what you need to do is shut down your company for a while, exit, then sign a contract with Uber. It should be probably both here, but sorry, it was demo in different environment. And in that contract with Uber, you basically say, hey, Uber, you know what, we make a deal. If my van is not functioning, I'm just going to use your services. And this is a different implementation of the transport process, which comes in different model, Uber transport. Okay, so then once you have this, you can start your business again. Except, sadly, because Java modular system is not dynamic, you have to tell it upfront when you start everything that you have, once and forever for the lifetime of it. So you have to say, I do have a Uber transport process as well. And so now that you've said that, you can run your business again, and when you say clean house, hey, you're using Uber now. You're not using your services anymore. But now, since you have both processes, what can happen when your van gets fixed is that you immediately fall back to your van. So Uber is just a plan B. Nice. But what if you want to do this without shutting down your business? Or what if you want to do this in Java 8? Or what if you want to do this without this boilerplate code? There's a solution for that too, unpopular one. Well, hated by a lot of people, but one that I'm really happy with. It's called OSGi. And this is the next example, which is pretty much the same thing here, except we don't have module info, we don't have all this new Java stuff. What we have is that our internal processes use annotation. So if I look at the transport process, you will see that I have a process annotated with this thing component, which is more or less the same thing you have with Spring. Basically saying, yeah, this is a service, and it does implement transport process. And then if I look at the front of the use cases, which is here, I have my processes referenced, which is the same thing as inject. And as a matter of fact, of the newest OSGi release 7, you can actually use CDI annotations to do this. This is just how it is normally done in OSGi. It uses another dependency injection framework, but that's not important. Now you can ask about what happened with the previous problem, like accessing things and stuff like that. Yeah, that's solved too. If you look at the company, for example, in here, let's go like processes, where it is. You have package info file, and in that package info file, you say, we export this package. And if you go to the internal, you see there is a package info file. You don't export that package. So all this stuff that you had to put in module info to say, I'm exporting this, I'm not exporting that, this is now done with annotations. Okay, so how that works. Finally, that's the final example, I promise. And I'm not going to bother you anymore with any of this. So house cleaning 8 and run with Java 8. Okay, it's a little bit different shell, but doesn't really matter. So I can do clean house for €100, and yeah, you know, this process works fine. So let's break the van. Status. And let's do this again. Oh, our transport process is broken. What we will do? Oh, we will do this. We already have a contract with Uber. We just never told anyone because we didn't know it was needed. But now that we know, we can just say install, go to our Uber thing, which is compiled somewhere here, and install it. And then we can see what's in there. Yeah, it is installed. It just doesn't start it. So let's start it. And let's see again. Hey, it's now active. Cool. Sorry. Clear, that's what I wanted. So I can show you clean house for €100. And here you go. I'm using Uber now. You don't have to restart my application. I just dynamically change the service. And what happens if my van is functional? Again. Now I'm using my van again. Okay. So this is what services are all about. This is where the whole microservices, REST, SOA before that, what was it called before that? Yeah, SOA, service-oriented architecture. There was another name before that. There's been tons of approaches which are basically an implementation detail of the very same idea. Your service is an abstraction, right? And it is how you implement it decides how many additional dependencies and constraints and slowness and all these things you want to introduce. You can do it simple, you can do it more complex. It's up to you and your use case. Which brings me to this point, which is a fairly known saying in the software industry, that two hard things in computer science: cache invalidation, naming things, and off-by-one errors. And I was struggling always to, I was using one of those buzzwords to illustrate that example, but I'm just going to use my recent experience from a talk that I gave earlier in another conference. So I was trying to tell people naming things is bad thing, because what happens is, take Agile, for example. A bunch of smart people got together, figure out a way of doing things, label it with the word Agile. Fast forward 10 years, and you have people arguing, is that Agile? No, it's not. Oh, it is. Microservices. Is it microservices if you don't do Spring Boot? No, it's not. Oh, it is. It's pointless. We're arguing about the word the same way you would argue with our kids about what clean means. Right? So, and I was doing this talk and explaining that it's not my point to coin another word. And then after the talk, someone came to me and said, hey, I really like what you said, what you described. How it is called? I'm like, yeah, that's the point. It's not called. I'm not coining another buzzword here. What I'm trying to tell people is, it doesn't matter what you call it. It's what you want to achieve. I've seen many, many times architectures that are bad, that I can look at them and say, this is going to cause problems in the future. But it's no way to explain to the people who doesn't have that experience. So the whole purpose of this is this talk was to show you how different decisions at different stages of developing applications are influencing the future of that application, because the only constant thing is change. And so it's the same, back to my point, it's the same about the cleaning children's room. Like, take a step back and think, why you ask your kid to clean the room on the first place? Is it that is because you clean freak? Like, you really, really freaking out about cleanness? Probably not. It's probably because you're worried about the consequences of that may occur if your kids does not develop the habit of keeping things tidy and clean. And it's the same thing with developers. It's not about arguing what clean means or what agile means or what or DDD means. It's about, my worries is that we have way too many developers who are driven by buzzwords and they don't foresee the consequences of not building proper, clean, tidy rooms. Because guess what? The cleanest and tightest room is going to get dirty and messy at some point. And the same thing is with your application. No matter how clean and beautiful it is today, it's going to get dirty and messy one day. And the whole point is to design it and evolve it in a way that keeps it safe and a livable place. Thank you.
Do you have any question, please?